I'm Jordan Veldy, and this is my Physics Lab 4 oscillations. The purpose of this lab is to observe the motion of a spring mass system as the mass is oscillating in an arc. I will compare the predicted motion and the observed motion and also determine whether or not the model system satisfies the energy principle. I determined that the system's total energy remains constant at zero and therefore does demonstrate the energy principle. For this lab, the fundamental principles covered include Newton's second law, which says that the system's change in momentum is proportional to the net force applied, and also the energy principle, which says that the system's change in energy is the sum of work done by the surroundings and thermal energy exchange within the surroundings. For this lab, my lab group chose to make our own video of an oscillating spring mass that we chose. I am also using the Tracker app to track the observed motion of the spring mass, and the GlowScript app to create a computational model that predicts and graphs the object's motion and energy changes. For the system of this lab, it's the mass, the spring, and the earth, and the surroundings is everything else. Here are pictures from the results from the Tracker app for the observed motion. The initial conditions from the data were the mass at 0.2 kilograms, the initial velocity, which was all zero, the initial position, which was negative 77.3 meters in the x direction and negative 184 meters in the y direction. The time intervals were 0.033 seconds, and the last recorded time was 5.57 seconds. For the calculated initial conditions, I had to solve for t using the equation t pi square root of m divided by k, and to solve for k, I had to use the equation 4 pi squared m divided by t squared, which gave me a k constant of 13.611. Here's a picture of the initial conditions in my code for the computational model, where I inputted the mass, the ball position, the velocity, gravity, the k constant, and the relaxed length of the spring. Here's a picture of the additional edits I made to the code for the spring and the system energy. I put in equations for L, L hat, S, kinetic energy, gravitational potential energy, the spring potential energy, and the total energy. Here is another picture of the edits I made to the code for the motion prediction loop. This includes defining the initial energies, calculating the gravitational force, the spring force on the mass by the spring, the net force, updating the object's velocity, updating the spring, and calculating the energy changes. On the right is a picture of the results from the computational model. Potential sources of error could have included, like in previous labs, that I possibly inaccurately placed the point for the center of mass on the Tracker app, and also that since the system is not entirely isolated from its surroundings, that there is work being done on the system by the surroundings. Analysis of these results. What does this mean? For this model, is the energy principle satisfied? Yes, according to these results, the energy principle is satisfied. Because there are no external forces affecting the system, we know that the change in energy must be zero. Looking at the graph on the right, we see many different types of energy shown by the different colored lines. However, the graph shows that the change in total energy represented by the orange line is constantly zero. When comparing the oscillation periods for the x and y direction, the x direction, the t value was 1.856 seconds, and the k value was 3.34 newtons per meter. And in the y direction, the t value was 1.894 seconds, and the k value was 3.20 newtons per meter. So the x direction had larger values for the k, and the y direction had larger values for t.